Hello. This is part 2 of transforming graphs. And to start with this time, I've got the y equals cos x graph. And I'm going to use quite a nice little idea on Desmos, where I'm going to put a number which I'm going to call a at the front. And I can change what a is. So here you can see that when a is 1, I'm just going to get 1 cos x, which was the original curve, which has been plotted in purple, but it's actually the red one. Remember, the red and the purple one are the same. One overlaps the other. Now watch what happens if I change a. So as a gets bigger, you notice that the curve starts to move, but the original red cos x graph doesn't all move the same distance. So I'm just going to stop it there. You'll notice that the points that lie on the horizontal x-axis do not move. So what's actually happening here is that we're telling the curve to multiply the cos x values by 2. So this purple graph is the graph y equals 2 cos x. This is called a stretch, and it's a stretch by a scale factor of 2. So that y value used to be 1, but now it's 2. This y value here, whatever it was, we could look it up if we wanted. We will look it up actually. Let's go to here. This value here, 0.755. If we double it, we're going to get about 0.51. So if we move up, it's 1.45, 1.5, there we go. So all of the values on the red curve have doubled. So that's why it's called a stretch, because the biggest y value stretches by the most. Of course, the y values that are 0 lie on the x-axis, and if you double them, they still become 0, so they don't move. We can see this happen even more obviously if we move it across and we let the value be 3. And here, look, you can see that 1 times 3 is 3, 0 times 3 is 0, 0 times 3 is 0. This value here, whatever it is, 34 degrees, 0.829. If we were to multiply the y value by 3, we're going to get roughly 0.24. So if we go to the purple graph, roughly get to 34, we're nearly there, 34, 2.4, as I said, 2.487. So you can see that what this is called is a stretch, and the graph is moving up and down parallel to the y-axis. So this is called a stretch of scale factor 3. This is a stretch of scale factor 3.5. So this is a way of changing a curve to make it stretch. So you don't want to move the whole curve up or down. You just want to multiply, increase the amplitude is what we say. The amplitude is the distance to the highest point and the lowest point from the x-axis. So the cos x graph has an amplitude of 1. If we want to change the amplitude, this is when we multiply the cos x graph by something, and here you can see it's by 3.5. So the amplitude is now 3.5 in both directions. So that's a stretch in the y direction, parallel to the y-axis, right? Parallel to the y-axis, that's the important thing. Now let's have a think about what might happen if we change this idea and think about how to stretch this curve in the x direction. So we don't want the a at the front now. What we want to do is we want to replace the angle with bx. Now, the original graph, of course, is if b is 1, then 1x just gives you y equals cos x. So these two graphs overlap at the moment. They're both the same. Let's see what happens if we move the slider along and we gradually increase the values again, and we're going to get to the value of 2. Now, it seems odd that that's happened. It seems hard to distinguish what's happened there, but what essentially has happened is this. The values on the original red curve have halved. So if you remember this value here, this is the value 90 degrees, and the y value is 0. Now that y value of 0 is the same on the purple graph, but you only need to use half the angle. So this time you're only using 45 degrees. So this point has moved from here to here. So this is what we call a stretch by a scale factor of a half. So all of the points on the red curve have been halved, in other words. So if we have a look at this point here, just about get this point here, the 360 here, that's on the red graph and the purple graph. But let's focus that as a point on the original cos graph, 360 degrees, and the y value is 1. Notice that the purple graph has a hump here. And if that value of 1 is maintained by halving the 360, so you need half of 360, you need 180 degrees on the new curve to get the same value you did on the old curve. So notice that if b is 2x cos 2x, then you only need to put 180 in here to get the 360 you would otherwise have in the original curve. So again, not all the points have moved the same distance from the red curve to the purple curve. The horizontal movement is by a factor of a half. So 360 halved is 180. If we go to this point here is 180, and if we half that, we will get 90 degrees. So that's a scale factor of a half. This was a scale factor of a half. And finally, this point here, we know that's 90, 0. This one will be 45, 0. And we know that. And that will give us, again, a scale factor of a half. And it works on the other side. So here's our minus 90. And if we half that, we should get minus 45, 0. So again, this is called a scale factor change by a factor of a half. The x values are halving. So the curve is concertinaed, being pushed in towards the origin. And there are twice as many humps, there's twice as many full cycles now. So originally 360 degrees is one cycle, but now you get one cycle and then another cycle. So the period has changed. It has a period of 2. So every 180 degrees, this purple curve repeats once, twice. So let's change it to 3, and we would expect a stretch by a scale factor of 3. So now we're going to get 3 waves, 1, 2, 3. So there are 3 full waves in the 360 degrees. So we're dividing 360 by 3, and that's 3x. So 360 divided by 3 is 120. Every 120 degrees, we're going to get a full cycle. So there's the peak. That will be at 120 degrees. So that's a full cycle. Then another full cycle takes us to 240, and then another full cycle takes us to 360. So again, this is a stretch by a factor of a third, because if you check all the y value, the y values, the x values on the red curve, that's 180. This is at the bottom of the curve. This is clearly the bottom of the new curve. If we compare it, this should be 60. We know it should be 60 because we should be doing a third of 180. Okay, a third of 180. So this is what we call a stretch by a scale factor of a third. Okay, it concertinas, it pushes the purple graph in towards the origin and squashes it all up, and you get 3 times as many full cycles as you did in the original curve. So that's what we call a stretch in the x direction. And now, of course, I'm going to stop it there because that's all that's required at this stage. So that's the second form of transformation. That is called a stretch in the y and the x direction. And just in case you were wondering, in fact, just go back and just choose this value to be half. Now, this half value means that we're looking at the graph cos a half x. Notice what happens this time is that the red curve for this value here, 180, the blue curve occurs, the purple curve has a minimum down here at the bottom and that's actually at 360 degrees. So it's twice as far away. So this has been a stretch by a scale factor of 2. Okay, so it does the opposite. So when you put half in there, the scale factor enlargement is 2. It stretches it further away from the y-axis. Okay, so you can see that by picking any value. If you try and pick a value, an obvious value, you can see that it has moved. So again, this value here, it's at minus 180, the original. It's now gone to minus 360 all the way here. There it is, minus 360. So it's been stretched by a scale factor of 2. You've actually stretched. Imagine the red thing as a piece of string. The red curve is a piece of string. You're just pulling out the blue one. And of course, this point wouldn't move for both curves because the angle is 0 for both of them. So if you put cos x and cos something 0, cos 0 and something 0 still gives you 1. So that's the point that doesn't move. All the others will stretch by a factor of 2. Okay, I hope that's helped. And oh yes, and just one other final thing. What would be the cycle here? It would be 720. It'd be twice as big. Instead of 360, it would be 720. So that is stretching, and I'm going to upload that now onto YouTube.